Good evening and welcome everybody. This is Obi-Wan Pez for Simplex Pachinko, and we are going to be working on Peter Liljedahl's Building Thinking Classrooms, Chapter 4 tonight. We are doing the question of what to do with furniture in a thinking classroom. So, the idea behind this entire series is that we are attempting to explore each of the 14 teaching practices that Peter Liljedahl teased out through a large amount of research in Canada and I believe some United States teachers as well. There were approximately 400 teachers that he worked with over about 15 years, and he ended up coming up with, again, like I said, 14 teaching practices that really pushed the boundaries of what was possible within the classrooms. So, generally speaking, the first principle that he was able to work out, which is kind of an overarching theme throughout the rest of the series, is that whatever the current model is, whatever the institutional norm is that students are used to, toss it out the window. So basically, if students get used to something and it becomes the norm, then they will tend to disengage, or at least tend to disengage more often. And earlier on, throughout the book, we started working on looking at the institutional norms and then therefore what kinds of practices we could work on as math teachers in order to change classroom behaviors and in order to make sure that students were more interested, more engaged. And so Peter came up with 5 categories of behaviors that existed within all the math classrooms that he was looking at. And some of these are generalizations, but they tend to work pretty well in order to check out the problems that existed and then address those problems. So the first was that students tended to fall into, like I said, 5 groups. There were those, approximately 10% of the students in the classroom, give or take, who would fall into the slacking category, which is that they just wouldn't do anything. They didn't care. They were just there because they had to be, and nothing mattered. There were 2 groups that are very similar to each other. Hey, Famished! There are 2 groups that are very similar to each other. One is stalling, and the other is faking. In both cases, again, somewhere around 10-ish, maybe 20% of the class in each group. And the issue here was that the students who were stalling and faking students would engage in non-mathematical, non-classroom activities, whatever it was that the teacher had intended for them to do, they just weren't doing it. The stallers, generally speaking, would go do something completely different, homework from a different class, talking with their friends, and not doing the work. Whole range of behaviors. Going to the bathroom, wandering the halls, etc. And the stallers Yeah, that was stallers. The fakers were then students who did legitimate classroom behaviors, but at the same time, they were not doing the work as requested. So they were doing things like sharpening their pencils or getting a quick drink of water out of, water bottle, but taking a really long time to do it. Or searching for their notebook because it must be in here somewhere. It's just hadn't gotten that out yet. In both cases, the stallers and the fakers both were intending to delay their actual thinking and work in order to move on to, or in order to let the teacher finish, and someone in the classroom would answer the question, and then they could take notes. That's basically all they were doing, is just waiting until they get the answer, or until they could copy whatever's on the board, or copy whatever the other person was saying. They just did not do the work because someone else was going to do it for them. Around half the class fell into a group called mimickers. And I've said many times, that was me. In all of pretty much high school, I was, well, maybe a little bit on the mimicking plus, or fell into both the mimicking group and the what's called just try it group. I was pretty enthusiastic about mathematics in general. So, the mimickers tended to look at examples that had been done prior, and then copy, essentially line for line, exactly what was being done in that process. And then, when they get to the end, or when they get to doing their own problems, do the just try, or now you try one problems, as Peter had mentioned, what they would do is they would go in and essentially just copy-paste all of the numbers that they got for this problem into the one that they just did in their notes, or is on the board, or whatever. So they're just looking to do a quick copy-paste job, looking to learn the process, but not really caring about the understanding of the underlying concept. As I said, that was pretty much me growing up. I was perfectly happy to just try some problems, but at the same time, every single time that I got to a new problem type, I would then look and see if there was an example that followed that exact same thing. And if there was, then I used that as a template. If not, then yeah, I'd have to think about it a little bit, but I would go for the last group, which is tried it. About 20% of the class fell into the just tried it group. And these are approximations. That's not exactly 100% accurate here. Every classroom was a little bit different, but he's found that these percentages were, approximately correct. The just tried it group just literally tried it. They took their notebooks, they wrote down the problem, and they started working at it. Most of the time they would work at it independently, and then when they had problems, they called the teacher over. Occasionally, they'd do the literal thing the teacher says, think, pair, share. They would get stuck, they'd ask their neighbor something, and then do whatever. This is essentially the intended behavior of any mathematics classroom, is that we want students to attempt to do it independently, ask peers if they have any information that might help them get unstuck if they are stuck, and then getting toward a answer solution, they would be able to then share that information with the rest of the classroom. So that's the idea. And then, in order to facilitate these behaviors, lean more heavily toward the just try it group. So everybody, hopefully, that's the idea, is going to shift in this group setting to hopefully be in the just try it group. Maybe a few mimickers, especially if they were The slackers beforehand, they did not care whatsoever. Hopefully, they would get a little bit better into doing other stuff. All right. I know you don't like ChatGPT. Yeah, pretty much. But what's your thoughts on a teacher's perspective using it to create quizzes or exams? So, no matter what you're using it for, it can only ever do a first draft. And even that, it's not good at it. You should never, ever, ever use it for something you are ever going to hand in straight off the presses. No. So if you want, ChatGPT to go through and be like, hey, can you create an exam on this particular topic, whatever it is? And it does, it'll come up with a whole bunch of questions on it. Most of the time, it'll even be correct, right? It is about that topic. But I guarantee it is not going to have the correct distribution or the correct, feel for the sorts of questions that you want to ask. So it's great for, just create a random problem and then pray. No, I mean, it's good for, a review set. Right? If you were to go in there and say, give me 20 problems that cover these 3 topics or something like that for a review, and don't even tell it it's for a review. Just say, I would like you to give me 20 problems on these 3 topics. It'll probably come up with something decent, but it's not going to give you, the right, like I said, the right feel for it, the right, the right teaching philosophy, right? It's not going to come up with anything sophisticated. It'll come up with a few things that you've probably seen before. It'll come up with stuff that it's scraped off of textbooks or that it's started to mix in with other textbooks and be like, oh, well, we'll create a novel problem type by mixing these 2 or 3 word problems together. Okay. You're right, I don't find that particularly interesting or helpful, but if you just need a quick and dirty problem set, sure. Use an AI system. There are probably other ones that are better than ChatGPT as well, and I haven't explored that space at all. I just don't care. One of my kids' friends' fathers is really big into AI. And so, he does work with AI systems. He's been chatting with Claude and Grok and ChatGPT and a couple of the other ones to try to figure out some stuff. And, he knows the limitations of this stuff. He is not like all of your... if you know Angela Collier from YouTube, she is a brilliant physics YouTuber. I've probably mentioned her before. Yep, A Collier Astro is her handle. But check out her stuff. She did one somewhat recently on vibe physics. So this was vibe physics was all about some of the tech bros being like, I was talking with ChatGPT recently, and we talked through some of the basic stuff about physics, and it got it all right, and I was really enthusiastic about that. And then we talked about stuff that's at the edge of physics, and it thought the stuff that I was saying was a great idea. And she's like, now why do you think that might be? and went into a huge rant about it. It's wonderful. I recommend it extremely. And of course, the answer really is that AI is meant to be obsequious. It is meant to... Oh. I unplugged my tablet. I was wondering why it wasn't turning on. Alright, let's follow that back. We need to eject... Actually, you know what? I don't think I need to eject this. I think we can just plug it into a different USB port. I do have one available. Yes, okay, good. So anyway, yes. Angela Collier, A. Collier Astro, brilliant physicist. I believe she's just moved to Boston, and is working on like some pretty big projects recently. Okay, so how do we arrange furniture in... So the standard, the institutional norm, the thing that we're attempting to break away from. In a lot of, especially high school settings, even middle school settings, we've started hitting the rows and columns. Right, typically you've got a bunch of desks that are set up like this. Work smarter, not harder. Right, something that looks like this. 30-odd desks in a rectangular arrangement, all facing the board. The boards. And typically, this is also in front of the teacher's desk. It is possible that the teacher's desk is over here instead. I know in my classrooms, when I was working in the public schools, all of my desks were in the corner, and the students' desks were, arranged in rows and columns. Occasionally, we would get groups, and the most expeditious way to do this was groups of 4. So you typically have something that looked like this. Ooh, uh-oh. Oh no. That's too many. Oh. Yeah, give or take, that's laughable because there's nobody with that few desks. Right, typically we get something like this, give or take. A little staggered. So we kind of fit groups in. right? Something, give or take, looks a bit like this. So we could get our rows and columns, which look like this. Again, teacher's desks over here. In the group setting, I mean, it could be literally on any side, but that was the kind of idea. The one that I had in Baltimore looked something like this, where I had blackboards both at the front and the side. So that was pretty cool, that we could go over to the sideboard and do stuff over there as well. We had windows on this side, which was, didn't allow for anything to be done. And then my desk was over in the corner. So most often it was in groups, but, test days and stuff like that, it would be rows and columns like that. So this is our institutional norm, typically. And again, groups of 4 or maybe 6 if we were feeling especially ambitious and a class was like, well behaved in that they wouldn't derail conversations or just literally go and have side conversations while I'm talking. In groups of 6, that was often more likely. You have more people, you have more social connections, things like that. So they were more likely to talk to each other in groups of 6. But even still, this is suburban Baltimore, so there was a lot of discussion going on throughout the classroom. A lot of students did not see a point to being here, either because they weren't going to college, they did not see the point in math specifically. It doesn't apply to them, that sort of thing. I'm not the nerd. I'm not going to college. I'm not going to do math for the rest of my life, that sort of thing. Oh. So so all of these tasks, again, were being put out there so that Peter and his research teams could try and figure out what needs to happen to let students become better students, in that they need to spend more time thinking and yeah. Spend more time thinking while in the classroom. Right. All these practices have proven over and over again to increase the amount of time, but what happens when students and the teacher all go home and all that's left is the room and what is in it? Is this still a thinking classroom? Obviously not. If there are no students to do the thinking, it can't be a thinking classroom, or so I thought. In this chapter, you'll learn about the results of the research into how the physical organization of the classroom furniture affects student thinking and how any classroom can be reorganized to help optimize student thinking. Right? What is the optimization of student thinking given merely changes to the physical space itself? Again, institutional norms, rows and columns, or individual groups, generally speaking, groups of 4, because here that's just the easy way to group them. You shove the desks together, they're rectangles, they make rectangles. All right, mostly. So having rectangular groups of 4 is the obvious thing to do. Then, again, Peter says that the first thing we need to do is to break the norm.
Hey Spotify, this is Danny Howard. Ready to turn your holiday into a party? Defected Records has teamed up with Jet2 to bring you the freshest house tune. Perfect for
do literally anything else. So we end up with no, okay. Right, absent the students and the teacher, the classroom is an inert space waiting to be inhabited, waiting to be used, waiting for thinking to happen. It's not to say that the classroom in its inert form has no role in what happens in it. We already discussed the first 3 chapters were about what types of tasks do we need to use in a thinking classroom in order to boost the amount of thinking being done. We also need to, where's my timer? Okay. We also need to determine how to make collaborative groups and where the students are working within this classroom. So for problem 1, what types of tasks do we use? The idea was that first we're going to introduce the students to doing some warm-ups, non-curricular activities at the beginning, which get students to think. So again, literally any sort of thinking type problem. You can have brain teasers, you can have all sorts of cool stuff that's in here. And again, thank you to Sunil Singh. One of the examples that he gives is the cubic equation, right? When does the sum of 3 cubes add up to an integer? And you can come up with any number. Generally speaking, you say, okay, look, X, Y, Z are going to go lowest to highest in that order. If there are any ties, they're just ties. Don't worry about it. Obviously, it doesn't matter what order they're in because they're the same number. But just go lowest to highest. Again, each number, X is less than or equal to Y is less than or equal to Z. And then you're summing up the cubes of them in order to get an integer. So how about, what would you do if the answer is 1? Well, no, that's slightly harder. What if the answer was 3, right? If n is 3, well, this is an easy one. You say that, I guess 1 is also easy. Right? 0 is 0, 0, 0. 1 could be 0, 0, 1. 2 could be 0, 1, 1. And 3 could be 1, 1, 1. Right? You cube each number, you still get either 0 or 1. That's nice and easy. Then you say, okay, now what about the sum of 3 cubes equals 4? Right? So then how do we get 4 from 3 cubic numbers? So this becomes a little bit harder for them to think about, okay, what do we need to do in order to get those particular numbers? Right, and we could always come up with other ones to do. So for instance, 8 is an easy one. It's 0, 0, 2. Right, 9 would be 0, 1, 2. 10 would be 1, 1, 2. And then what about other numbers that are immediately surrounding it? Well, 7. Thinking back to 7, we could do, okay, 8 is 0, 0, 2. And 3 is 1, 1, 1. So like, what would be the easiest way for us to get 7 out of this? Well, in this particular case, turns out that using a negative number is perfectly allowed because we're using cubics. Nobody ever said, right, the sum of 3 integers. We never said they had to be positive. So we end up with, okay, 7 is negative 1, 0, 2, and 6 is negative 1, negative 1, 2. Okay, so that's 8, 7, 6, and 0, 1, 2, 3. what about 4 and 5? And then we can continue with all this discussion as well. 8 and 9 and 10 we already had. So what do we do when we go to 11, and then 12, and then 13, and etc.? You can try to get more and more of these numbers, and it becomes a little bit harder every time in order to find one, because there are a whole bunch of different combinations that, in theory, could get close. Right, another good one. I didn't bookmark that one. So Sunil Singh says in this, one thing to do for one thing to do for lessons is we could start with a curiosity that then is very odd, and it allows the students to start discovering what exactly is going on in these particular cases. So one of the examples is he holds up 6 of the little cubes, the unifix cubes, that'll stick together one into the next. And this is a bunch of 6-year-olds, right? So he counts them. Everybody gets to 6. Okay, cool. And then tells them a secret that 6 is a perfect number. Everybody needs to know this is, this is a secret. How's it going, Zach? And I asked who wanted to know why. Every single hand in the classroom went up. Of course, right? You've got a secret. You want to keep it quiet, and everybody wants to know what's the... Hello there. Right? What is the secret? So he took the oh, bloody hell. Okay. So he took the 6 unifix cube and he had a group of testers, which are, as we know them, the proper divisors. So 1, 2, 3, and 6. Well, 1, 2, and 3 of groups of unifix cubes. So he takes them and he says, like, how many times can we stack, or how many times can we run the 1 along this 6 in order to get all the way to the end? And of course, 1, 2, 3, 4, 5, 6. Everybody count together. All right, what about this tester with the 2? So you test with the 2 and you go like this all the way up, and everybody gets that it counts 3 times. You get the 3 tester and it counts twice going up like that, and it makes exactly the same length as the 6. And then you take the 4 tester and you notice that, oh, that doesn't actually fit. So our 1, our 2, and our 3 testers are the only ones that are going to work for this 6-length unifix cube. And then he takes those things and stacks them together, and he gets 1 6 length that's exactly the same as the other one. So he's essentially taught a bunch of, kindergarten first graders, basically, about how proper divisors work and perfect numbers. So obviously you want to do something a little bit more engaging to the proper age level. But nonetheless, something like this. Okay, what do you think the next perfect number is? And then yeah, he says he puts a bag of blocks on every table, and there are 3 to 5 students, and asks them, find the next perfect number. It's under 30. Ready, set, go! And then all of them start working to try to figure it out. And he said quickly, students were able to figure out that they only can actually build even-numbered towers after a little while, and then went with their testers to figure out a whole bunch of stuff, and then a bunch of them came up with false perfect numbers, but chances are they just missed one of them, and they go back and check, and oh yeah, okay, it stacks too high or it stacks too low or something like that. He said the whole classroom felt like a game show. Who was going to find the next perfect number? Game continued with unabated electricity, courtesy of both mathematics and the students. And about 15 minutes into the activity, he said, I could have just told them what the next perfect number is and explained why in 15 seconds. But there's no magic there. There's no messy middle. There's no messing around trying to figure out the problem itself. Without these little kids realizing it, they were going to be skipping through this rich path of thinking for the next 30 minutes. Sure enough, after that time, a group of 5 girls who were jumping up and down like they were at the trampoline park had succeeded and found that 28 was the next perfect number, and then had the testers to show that yes, it's 28. I then asked them if they were ready to find the next perfect number after 28. Many of them seemed up for the challenge and said, oh no. No, we don't have enough blocks. Why not, right? Everybody in the classroom asked, why not? Because the next number is 496. And even before they finished their gasping, I wrote 8,128 and 33,550,336 on the board, which are the next 2 perfect numbers after that, and turned around only to see bulging eyes. Not that this ice cream had needed a cherry on top, but I threw one anyway. And I told them that all of these perfect numbers also happen to be triangular numbers. And then they could go into triangular numbers at that point and discuss a whole bunch of stuff. Now, how would I do this in my community college classroom? I mean, apart from the slight condescending teacher tone that a lot of people end up taking with elementary students, not a whole lot needs to change, because again, you just say like, hey, so what do you guys, have you ever heard of this thing, perfect numbers? No? Okay. Well, why would something be perfect? Oh, it lines up perfectly. Okay. Well, how would something like, I'll let you know that the number 6 is a perfect number. Why would it be a perfect number? I'll tell you that it has something to do with its factors. So we've been talking about factoring and a bunch of other places in here. So, what are the factors of 6? Okay, what do you think? Like, what relationship do 1, 2, and 3 have to 6? Oh, look at that. They all add up to the exact same number, 6. Okay, cool. And then in your groups, I want you to find the next perfect number. It's under 50, right? Go. And my students at the community college level would be like, ooh, this sounds like an interesting challenge. And using something like Unifix cubes would be an easy, attainable sort of thing. We have teacher ed stuff. There's a paper you like about students trying to reason about -2 factorial. I imagine there was a lot of yelling. It's an investigation into generalizations of a high school class into generalized factorials. Nice. I'm gonna have to look that one up. Yeah. Mm-hmm. So that's the kind of tasks we want to start with, is start with these non-curricular tasks, usually about 15 minutes of your first class, usually it takes about 2 or 3 whole classes in order to get students primed to be like, we're doing this now. Like, this non-curricular stuff is going to be the backbone of all of our, like, warm-ups. Then, once you get into the swing of things, so for us, this is a full week, right? Either Monday, Wednesday, Friday, or Monday, Wednesday, Tuesday, Thursday. It's a whole week of doing this. It could be upwards of 4 hours, right? Maybe 5. Depends on which group of classes you have, but usually it's 4 hours. And then at the beginning of every class from then on, we do one thinking activity, and then it leads into something that's not obviously curricular. It's sort of another like connection / warm-up, something that's a little more mathy, something that's a little more serious into the stuff we're talking about, but at the same time not explicitly curriculum stuff. So like a puzzle that exists within material that you've covered already. Or you start with like the priming question for the actual curricular topic. But typically, again, we're going like one task that is completely non-curricular, one task that is maybe semi-curricular, or then we could also potentially prime the pump, as it were, to ask the question that's going to get them thinking about the thing you want them to think about. NCTM 2017. Man, I just gave away all those. Yeah, gamma function. Okay, and then in section 2, we talked about how we form collaborative groups. So collaborative groups should be formed by visibly randomizing into groups of 3. So the way that I had it was we get 3 cards of each rank and then shuffle them all together. It is equal to the number of students in the room, and if there are any students that you are expecting to not be there, somebody's sick, somebody said they're going to be out for a week or whatever, then you just remove that number of cards and you wait until everybody filters in. And they just start pulling cards out of the pack. When you end up with groups of students who are like singles by themselves, you can say, oh hey, just real quick, work with this group until your other group mates come. Usually becomes pretty easy to do that because they're geographically right next to each other, right? So you two going across the room, these groups all work together. If they're lacking more than, if they're lacking numbers. Generally speaking, again, students were interested in getting there on time, getting their assignment, and getting started. So I didn't have to really pull teeth on this. Typically, we had a slightly higher attendance rate in terms of like students weren't skipping class outright. So that was nice. And the third chapter we talked about last week was where do students work in the classroom? And the answer again became standing at vertical non-permanent surfaces, and those should be visible to everybody in the room as best you can. Nice. I'll read that later. Right. So then today, again, we're talking about how do we arrange the furniture in the classroom. Classroom with lots of vertical non-permanent surfaces allow for the possibility of a different type of learning experience than classrooms without them. But how a classroom is set up goes well beyond whether or not it has whiteboards. So he goes on and says, well, the problem is that every time we worked in classrooms that were super organized, again, desks or tables in perfect rows, in baskets, out baskets, for all possible eventualities, everything color-coded and in its place, we had more difficulty generating thinking. It didn't matter whether we were experimenting with vertical surfaces, random groups, how to answer questions, doing homework, or anything else. If the room was super organized, we had more difficulty generating positive results at all. So this seems a little bit wild. And then when we worked in classrooms that were disorderly, but not like slovenly, we had better results. So what was it about these super organized classrooms that were negating some of our otherwise effective practices for generating thinking? So it turns out, thinking is messy. So because thinking is messy, this overly organized classroom where everything has its place and everything must be in order prevents this messy thinking from taking place. And the students don't want to take that risk inside of their classroom. They'll look at the overly organized nature of the room and think, this is not me. Like, this is not how I do stuff. But slightly messy places, not overtly messy, but something that is like, you know, where do we hand in homework? It's just, over here. Where just, this area of my desk would be great, thanks. What do we do with, where's the hall pass or whatever? It's over in that corner. Some vague waving, hand wavy type stuff does a lot to promote this idea that this is a slightly messy place. It's going to get messy. It's going to be allowed to be messy in here, and you have a place here. Might be too hot to drink coffee around here. Might have to go get some ice when I go downstairs. Right? Requires a significant amount of risk-taking, trial and error, and non-linear thinking. And that's really... right? That's really where we're going with this, is that nonlinear thinking that we talked about in some of the previous ones ends up getting diminished because students don't think that they're allowed to take risks and try something that they don't know if it's going to work, right? They have to do the linear thinking process. They have to know what the next step is, and the next step is, and the next step is. And the reality is that that comes with time and practice and effort, just like anything else in life. You're not going to end up being perfect on the first go in baseball. So why would you think that you're going to be able to do this the first time you try it in math or in science or in English? You're not. It takes practice and effort. All right, on the other hand, thinking should not be completely unstructured. It needs elements of representation and organization for patterns to begin to emerge, and therefore overtly chaotic spaces didn't work either. Right, so we have this dichotomy that's going on of something that's completely unstructured over here and something that's completely structured over here. Super organized classrooms, feeling and getting messy doesn't really work over here, and getting organized doesn't really work over here. When we look closely at the types of classrooms from which positive results were consistently emerging, it became clear that they were neither too organized nor too chaotic. They were relaxed spaces in which students felt safe to take risks, try, and fail. At the same time, they were not so chaotic that the physical structure of the classroom became a distraction to the students, which is really where that comes from. So, oh, wait, no. Right, so stuff over here. Ends up becoming distracting. Can't get organized, right? And over here, this risk-taking, non-linear, messy thinking don't feel acceptable. Whether or not they are is not the point, right? The problem is, what do students feel like? And so we have here this sweet spot in the middle. Again, relaxed, safe for risk-taking. So, classroom needs to have a just right amount of disorder for thinking to flourish, and we wanted to find this minimum amount of disorder that was necessary in order to help the students then thrive. So, how desks and tables are arranged in the classroom says more about the kind of learning behavior, and hence thinking behavior, that is expected in that room than anything else. So they showed pictures of classrooms, empty classrooms, no students in it. Just pictures of empty classrooms with tables, chairs, no furniture, different combinations in different orders. And they said, let's try just asking them, what does this feel like? If you were to walk into this classroom, what are your immediate reactions? And so they would get students to submit some ideas in terms of, like, how do you feel based on these pictures? So. Again. Right, so he came up with a few questions, such as, how does this space make you feel? Is it conducive to risk-taking? Is it conducive to thinking? Is it conducive to, like, collaboration with other students? And they come up with this multi-dimensional analysis to figure out what exactly is going to work the best for the students that they had. All right, ads are going to start in about 3 minutes, so we're going to try to get through, like, a little bit of this. A teacher may have a relaxed attitude about precision, but if the desks are in razor straight rows, that classroom is telling students that orderliness matters, and it's pretty much the exact opposite of what the teacher is saying out loud. Again, it does not matter what the teacher is saying if the room is telling them something else. So Peter says, think about the last time you went to a professional development session. If the room was full of chairs with no tables and had a podium, what do you think's going to happen? Right? You were sitting there and you're going to be lectured at. And you knew that this was going to be the case way before the session even started. If you walked in and there were tables neatly organized into rows with chairs only on one side, so everybody's facing front, then you knew you were probably also going to get a lecture. But maybe with activity. If the tables had chairs all the way around them, you knew that there would be time for discussion amongst the people who were at those tables. In short, when you walk into the room, you know immediately what to expect, and that expectation shaped your behavior. In some cases, you might have turned and walked straight back out. Also true. Called out. If that wasn't an option, you might have chosen to sit in the back, or in some cases, sit with your friends, or done something else in particular because of what you saw in that classroom or what you saw in your professional development session. So how the furniture is organized in the classroom makes a difference. In a thinking classroom, how the furniture is organized turns out to make a huge difference. Furniture placement sends a message, and what message you want to send is something you must think about. So anybody who's going to be in charge of a classroom in the next year or whatever, think about that. A thinking classroom needs to be organized in such a way that it says thinking, collaboration, and risk-taking are expected. Rows of desks do not achieve this. Even if the desks are put together in groups of 2 or 3, neither do neat rows of tables positioned so students all face the front. These are antithetical to the message we want to send. All right, we'll be back in 3 minutes. It's ad break time. Thank you so much for everybody for coming in. Everybody, yes. See you in 3.
come to the end of the road. There's no point in running away now. I'd rather sleep until the storm is gone. She'd rather be shooting at me now. I know it will end up in anger. I don't think we grew up, we just became older. She's aiming her words, ready to fire. I don't think that bullets will bring back desire. Like a blink of an eye's not enough. She'd rather be staying for days now. I'd rather fix it than mess up again. She'd rather be burning it all now. I know it will end up in anger. I don't think we grew up, we just became older. She's aiming her words, ready to fire. I don't think that bullets will bring back desire. I don't think that bullets will bring back desire.
Well, that's not quite working out very well. I need to figure out... That can't be entirely... Yeah, it's still... We're getting not focus. It could also just be a really crappy resolution. Ugh. Don't do that. Oh, that's zoom. Oh, okay, never mind. Ooh. No. Okay, I think that's actually better. Okay, we are going to... Oh, it's really hot in here, but you know what? We got to get in the habit, so... Alrighty, so standard arm curls, 20-pound weights, just under 10 kilos for those with reasonable units. Hope everybody's having a good start to your week. So in doing this Peter Liljedahl stuff with building thinking classrooms, I did in fact run building thinking classrooms for the year and a half that I was still there at my community college. So at first it was just the activities and the stuff in the classroom, and then when I got to the full semester, which was my last semester there, of attempting all of it at once, which included the grading, all the stuff that's really far ahead in the book. I had some mixed success. It all really hinged on a couple of things that did not work for me, just because I don't have a super great organization style, if we're honest. And so some of the stuff ended up not working terribly well. Okay. Just do some Tai Chi type of warm-ups here while we're at it. So again, the idea with this is to just get your joints moving and get the fluid working into the joints by just relaxing entirely and letting your arms fall where they may. What you're really doing is using your shifting body weight like a swing, where you are just like when you pump on a swing, you put more of your weight down as you're coming forward to the bottom of your swing, and that allows it to kind of you pull your body weight back up again as you come off the bottom, and that allows you to gain overall momentum. Some really interesting physics when you look into it. But yeah, it was something you do in the game called Worms, when you have your worms on a rope. You need to swing back and forth, or grappling hooks. It's totally ridiculous. I loved it. It was such a great game, and it was in college, so like we just played with the entire floor. All right. Nope, that's not that one. Okay. Next question. My Leatherman. Oh, right there. Okay. Good times. Righto. Tonight we are hashtag not sponsored by Green Dragon Craft Cider. In memory of the necrotic dragon that we slayed the other night. It was last night, yes. Our D&D campaign got to the end. Finished level 7. I'm sure we would have leveled up to level 8 next time had we done it, but whew, yeah, okay. That is definitely different than the one we had the other night. Whew. Combining Yorkshire and Herefordshire cider apples with local heritage varieties, as well as dessert and culinary apples to tailor our unique vintages. Right, so this is very clear. Toby's is a dinner theater that was near to where we were in the Baltimore, Washington area. And then we just gently swirl it a little bit. It gets quite cloudy. Yeah, you can definitely taste that 6%. Wait. Wait. I don't see a Best Buy date. That might be the problem. Well, anyway, yeah, this is vintage 2021, so, given that it's 5 years old, it's probably fine. Doesn't taste bad. It's just that it was not sweet, which is actually like a fairly normal thing for actual ciders, because the yeast and whatever else has eaten up all of the sugars. Almost smells. Almost smells slightly leathery. Anyway. Okay. In the efforts to place furniture in its optimal locations, right, showed students pictures. Deeper probing revealed through questions, interviews, etc. These assumptions extended to the expectations of students and their behaviors, that they would be orderly, their desk and their work and personal spaces would be organized, and that disorder would be frowned upon. While some of the students expressed an appreciation for this kind of order, the majority of students expressed that being a student in such a class would come with a lot of expectations and pressure. In short, straight lines was, good or bad, communicating what was expected in those rooms. So, this is not going to come through terribly well, but got a bunch of pictures of classrooms with various states of organization. Symmetrical furniture placement, placement of desks into horseshoes or circles, placement of tables such that all tables are parallel to one another, as it turned out, also conveyed an expectation of order. Because symmetry is often a byproduct of straightness, the result was slower to emerge. The same issue was true of fronting, where all things were facing one particular direction in the classroom. That is the front of the room. Everywhere else is not the front of the room. Placement of chairs so that all students face the front of the room. Fronting the room, like straightness and symmetry, communicates that order and compliance are expected in a room. It also communicates that the students will be doing a lot of watching and listening.
Hey, it's Sam Devine here. Are you ready to turn your next getaway into an unbelievable dance floor moment? Well, I've created a brand new playlist on Jet2's Spotify channel. It's packed with uplifting house anthems for every kind of escape, whether you're chasing those sunsets across Europe or simply vibing at home. However you holiday, let my beats be your soundtrack. Check out my summer soundtrack right now.
We'll be doing watching and listening more than doing. If all three of these furniture characteristics, straightness, symmetry, and fronting, are present, then students perceive the room to be very orderly and expect that all activity will be centered on the teacher. Straight rows, symmetric, groupings, shape, whatever. Right? A lot of teacher-centric activities. Applying the contrarian experimental methodology, these results told me that what we needed to try to do was create spaces where the arrangement of tables and chairs, desks, whatever, was neither straight nor symmetric, and where chairs were placed in such a way that the room was not fronted. Okay, so we get into this style which is called defronting. Right, not straight, not symmetric, facing all directions. Most students reacted positively to all of these pictures. Whether students liked or disliked them, however, all students predicted that the teacher would be fun and relaxed, and that all students thought there would be a lot of student-centric activity. right? Communicates fun, relaxed atmosphere, and student-centric. Activities. The second result that emerged from this experiment was that we only needed to defront the classroom in order to also de-straighten and desymmetrize it. As long as we defined defronting as ensuring that every chair in the room was facing a different compass direction. Doing so automatically ensured that there would be no straight or no symmetrical furniture placement. Second experiment was to actually teach in such defronted spaces. Using random groups and vertical non-permanent surfaces added further constraints to the placement of furniture. First, we needed to arrange the desks and or tables in such a fashion that groups of 3 could sit together. Second, we also needed to make sure that there was room around the perimeter of the room for groups of 3 to have easy access to the whiteboards or whatever, as students worked, discussed, and moved around the room. Given that most of the student activity was happening at the vertical surfaces, we were wondering how furniture placement in the middle of the room would affect student behaviors and attitudes. We didn't have to wait very long. The very first room we defronted was a grade 7 class that had already been doing vertical surfaces for a few weeks. When the students walked in, one of the boys immediately remarked, "Huh, guess that's how it's going to be now." When I caught up with him later in the lesson and asked him what he meant by that, he told me that the way the desks were placed meant that the teacher was never going back to teaching the way she used to. Right, so one of the things you have to make sure is that students realize that you're not going to give up on this whole new thing that you're doing, that you are in fact going to be doing this new thing for the entire semester, year, possibly your entire career, right? This is something that you're not going to just give up on and go back to the passive style. Right? We are not going back to these passive styles. We are not going to allow you, the student, to sit there and do nothing. We are going to push as hard as we possibly can to make sure that you are actually thinking in this classroom. Even when we defronted classrooms wherein the teacher had made no other changes to their teaching practice, students immediately commented on desk placement as something indicative of further changes to come. And of course, changes did come in all the rest of these classes. Defronting the room had an immediate effect on both students and teacher. Students began to collaborate more. Teachers started talking less. And that by itself is actually an improvement. From interviews with teachers, we know that they place their furniture to suit their intentions. This, it turned out, is not a one-way street. The placement of furniture also shapes the teacher's intentions. It shapes their actions. We also noticed a marked decrease in how much the teacher talked, right? We also saw a decrease in how much they demonstrated things at the front of the room. So demonstration time is also down. So you might think, well, this isn't a good thing. You're supposed to be demonstrating. You're supposed to be showing students what they should be doing. Sure, but at the same time, like, you want them to be more independent. You want them to work together rather than relying on you specifically. I mean, 99 times out of 100, right? If a student can get some piece of information from another student, even before this whole building thinking classrooms thing came out, I was almost always interested in making sure that they could get that piece of knowledge from another student rather than me. And I think that was probably brought up in multiple professional developments along the way as well, at some point. And like I said, building thinking classrooms typically ends up being the culmination of every single one of those professional developments that I went to and said, oh, that would be a nice idea, and used it for, like, a semester, and then just kind of let it go by the wayside because it by itself was having almost no effect, and typically was more, I mean, essentially, right? It's more work than it's worth. So there were some teaching practices I'm sure I kept at. One was trying to do Socratic thinking much more, trying to ask questions that would then get students to think more, but the problem was that it always became a conversation between me and one or two students. It was never really a conversation between like 3 or 4 students that I would then facilitate. Even if it was 3 or 4 students, it was still only 3 or 4 students instead of, 20. Yeah, I think I'm going to give up on that cider. I didn't notice it was 4 years old before I took it into my house. And maybe it's fine, but at the same time, it just not quite. If it was new and it tasted like that, I'd probably still drink it. But it being that old and Okay. We wondered what other alterations we can make that would have the same power as defronting the classroom, but in fact, further refinements to how desks and tables were placed yielded no better results than defronting. So defronting appears to be the local maximum for for student thinking. That was the singularly most effective thing we could do in terms of room organization to induce student thinking. Okay, so FAQ. What do I do about my desk? Where do I put it when there is no front? Most teachers have their desk at what has been conventionally called the front of the class. However, in a defronted classroom, it can go anywhere. However, as part of the defronting process, it should be moved to another part of the room. Otherwise, the students will continue to think of that as the front. If you come in with a defronted classroom on day one, again, it doesn't matter where your actual desk is. Mine was in the corner back when I was teaching in the public schools. And, you know, all of our desks at the community college were basically in the center of the front board. So, like, there was no moving anything. In a lot of the places where we had classrooms, what we did was, or there was a group of 4 desks, maybe 6 in the middle. The group of 4 desks, generally speaking, had floor conduit. Like, our floors were hollow. So they had 6 inches or so of a riser that would have all of the Cat5 cable, all of the Ethernet running around the entire room. So you had about, like I said, 6 inches of floor that was false. That was all just conduit underneath. And then it went up into the desks at those locations. So you can't move the desk without, like, unplugging the computer that's inside the desk. And then there's just a whole host of problems, including trying to move these things, which, I mean, they probably weighed as much as my desk here. But they were basically half the size. Otherwise, students will think of where it was placed originally as the front. Place it somewhere near where it used to be the back, but make sure it doesn't block any vertical surfaces that you want to use. What do I do about my projector, interactive whiteboard, clock, whatever? It's currently fixed at what used to be the front of the room. Okay, well, can't really do much about that, so if you can, move it to another wall. Otherwise, just live with it. It's fine. The important thing is to not reinforce that is the front. Don't leave a projector or interactive whiteboard running unless you're using it. And when it is on, make sure that, as much as possible, you're somewhere else. That is, use your position in the room to contradict the projector, interactive whiteboard message that that is the front. If your only remnant of a fronted classroom is the clock, go to a discount store and buy 3 more. I teach math in a science lab where all the tables are bolted to the floor. Yeah, there you go. How do I defront that room? Well, there are 3 elements that go into fronting a room: how the desks and tables are arranged, where the students are seated around them, and where the teacher positions themselves. Being in a classroom where the tables are fixed to the floor defines only one of those 3 elements. You could still disrupt the other 2 by positioning chairs on all sides of said tables and making sure that you spend a lot of your time in other parts of the room. One of my colleagues loved to do this by just walking with his iPad around the whole room, and he could directly project whatever he wanted up on the whiteboard. So he would just write, no matter where he was in the room, he could write and it would appear on the board. He was still using a fronted model in that case, but he was again contradicting the message that that is the front by being somewhere else himself. I share my classroom with another teacher who likes the desks to be in rows. How do I defront the room when they do not like that? A willing class of students will rearrange the desks in a room in less than 1 minute. Have your students defront the room as soon as they come in. Just prior to turning the classroom over to another teacher, have them refront the classroom. Some teachers place 2 small maps of the room on each corner of the desk. The first shows the desk arrangement in a fronted classroom, and the second shows the arrangement in a defronted classroom. On each map, one desk is in the arrangement shading in, telling the student that desk occupies that space on the map. Some students will come to class, grab a desk, and move it into its correct position without even having to be told. I have big tables in my room. How do I keep students in groups of 3 when I need more students at each table? Sometimes the size of the tables is not commensurate with your desired group sizes. In these cases, it's better to have the students squished when sitting than when standing at vertical non-permanent surfaces. So if you're going to have any issues with this, again, squish them in when they're sitting at the tables, and then once you've got your groups, go to the whiteboards, go to the whatever else you've got over there, and then you don't have to be sitting. That also allows you to spread out. If you're squished at the table, and then you can stand up and get more room, now it feels almost exhilarating to stand up and get away from that desk where you were all crunched in together. This will reduce the amount of... If you have big tables, put 2 groups at each one. If you have small tables, put 1 group at each one. This will reduce the amount of furniture in your room and give you more space around the perimeter, which will be useful when we get into consolidation later. Less furniture also allows the possibility of an empty space in your room, which is beneficial and will be discussed in 2 weeks when we discuss Chapter 6. Okay. So, macro moves, defront the classroom. Micro moves then. Cluster the desks and tables away from the vertical non-permanent surfaces. All right, position. Such that chairs all point in different directions. Try to avoid standing out what used to be the front. And move around the room while talking. While addressing the whole class. Right, when you're addressing one student and you're explicitly just talking with that one student, obviously you want to share the same space. But if you are addressing the whole class, be that, you know, a single student's question that needs to be answered for everyone, or if you're doing some sort of like mini lecture component, which we'll talk about later, then you want to move around the room as much as possible and not just stand in one space and not stand at what used to be the front. So keep moving around a bit, talk a little bit, walk and talk. You can move through the space that used to be the front of the classroom, but you don't want to stop there and like give the students any impression that you are favoring the front of the room, what used to be the front. All right, so what are some things in this chapter that immediately feel correct? Again, for me, this was kind of like, I've seen stuff about this in professional development. We want to keep moving around the room. You don't want to be at the front. You do not want to be anchored to one spot. You personally just need to not be in one singular place. So try as much as you can to move around as much as possible. What else? Yeah, as soon as I heard about, defront the classroom and start making it so that you're doing stuff more in groups so that you get higher student collaboration. I was like, I've kind of always wanted to do this. Again, I've heard some of this in professional developments and whatnot. So the fact that doing things collaboratively and trying as much as you can to not be at the front of the room yields higher results in terms of student thinking, again, is not really a mystery, I suppose. And the idea that the way in which the furniture is structured around the room tells the students pretty much everything they need to know about that class itself and its expectations. And having him point out that, hey, you remember when you went to a professional development and it was shaped like this? What are you doing? Yeah, okay. That makes complete sense. Think about the way your furniture is currently arranged. Is that a benefit for your students? So I have taught in multiple arrangements. We have rooms that are very strictly in rows and columns. We have others that I'm thinking explicitly of one or two rooms which were set up in the group of 6 in the front, 2 groups of 4 along each side, and then a row of 4 all the way in the back. Maybe 6. And these were the ones that were anchored to the floor. So you can't actually move the desks. It doesn't work. You can move them a little, but again, each of them has a Ethernet power, etc., that is directly underneath them. And if you tried to shift it around, it would probably damage the cables. So you can't really shift them much, almost at all, ever. In order to defront those classrooms, basically we just, as much as we could, I walked around the room. I had students sit in their swivel chairs and face each other and look at each other while they're all talking. And I would sit way back in the corner at a desk, on top of a desk usually, where nobody was that particular day, and we could have a conversation like that. And oftentimes they'd kind of be amused that I'm sitting, buttoned down in khakis, cross-legged on a desk. And most of the time I weighed about 165, so I could get away with sitting on the desk, which do have a tempered glass hard top that you can see through. So I had to be a little careful, but Yeah, it was like mostly wood, or the frame was wood, and then it had a tempered glass bit in the middle. So I could kind of like sit right on the edge of the glass, and it would be okay. Some people were like, "What are you doing?" I'm like, "No, no, no, it's fine." What is it that you like about the way your furniture is currently arranged, and why do you like it? So the place with the rows and columns, I don't really like it, but the fact is that those could be moved, right? Those were super easy to move around. You could have a roundtable discussion. Just set up so that everybody in the room is facing the center, and you're in one of those attached seat with a desk, which kind of stink, but whatever, it's fine. Anyway, those were flexible, and I liked flexible rooms. The ones that had the anchored desks, I didn't really like all that much, but at the same time, again, we could just treat a different area of the room every single day as, where I'm sitting or whatever, and then I would get up, I'd go to the board and write something, and then continue walking around the room to go somewhere else to continue the conversation. I didn't like doing a lot of that stuff because it was like hard, asterisk. It was not difficult, but it challenged my authority in the classroom, I guess. I didn't like that so much, not because I'm a control freak, generally, but because it often got students to just kind of get distracted about things. It was comforting to be the person at the front of the room who had, all the answers of my 15 years of experience and all this other stuff. It was great to be able to walk up to the front of the room to show the students how to get from point A to point B, and it was a security blanket essentially. But even so many of my immediate supervisors are like, get out of that well, right? Get out of the place between your desk and the whiteboard. Move around the room. And I couldn't, because I would just constantly be asking questions, and then when they ask a question, I would do something. And because I'm constantly asking questions, I'm constantly writing on the board. And it is a lot of the stuff that I do here on Wednesday nights, where I'm kind of doing the cracking the GRE stuff that we're doing. I would go up, and then we'd talk about a different way of solving something. We'd try to experiment by going off in a different direction. They would tell me to do something, and I'd be like, haven't done this before, and try it out. Let's see what happens. But it didn't help them any, really. It was more like it was helping me create a better lecture. But it's still a lecture. It's still sitting at the front of the room and telling the students what to do and how to do it. So it wasn't so great, especially in my last couple of years. I was feeling super jaded and just did not want to do the same old, same old. Think about other arrangements that you've seen, and why would a teacher prefer those arrangements? So, we had a universal design classroom where you could book your class into that particular classroom, and they had wheelie chairs, which were both a chair and an attached desk, which could move around the room in pretty much any way that you wanted it to. I think they had a basket underneath and maybe a pull-up desk. It's a bit like the lecture hall ones, where you'd reach to the side, rotate the desk up and then let it come across your lap. It wasn't very big, but still, it was the universal design classroom, so we could experiment and do all sorts of crazy stuff. I never could get my class in there, and it was also like halfway across campus, so slightly inconvenient for me. Very nice for the students because that meant they didn't have to go all the way to the math building. Somebody could go to the on-campus Starbucks and then roll into class in like 2 minutes, you know. Didn't have to plan ahead. So people really liked that because they could experiment, they could play, they could do all sorts of stuff, and they could defront the classroom super easy, right? Oh, what do we want? We want groups today? Do we actually want like rows and columns? We could do that. Do we want a round table? We'll do that. Right? They could do just about anything they wanted. It was great. In terms of like keeping everybody strictly in rows and columns, order, right? Making sure the students understand that these are the expectations. Some teachers want that. There are others who definitely don't. And groups, again, more collaboration. Maybe there's some other stuff to it. But at any rate. In this chapter, I talked about the straightness and symmetry. What else in a classroom and in teaching practice might be governed by a desire to have things be straight and symmetric? What, if anything, do you like about this, and what message does it send to the students? So, I mean, it was covered pretty much in the chapter here, but what else in the teaching practice might be governed by this ideal? I mean, keeping your homework organized and neat, being examples of linear thinking, having your exam, you know, the work on your exam essentially be linear, generally speaking, is seen as a positive. Doesn't have to be, but you know, a lot of people may see that. What, if anything, do you like about it? Again, like it's creating good habits in order to show the presentation of your ideas. But like your work should be yours. Your work should be as messy as it needs to be to fully understand whatever it is you need to understand. Then you should take that work and bring it over to your, you know, final draft and show how you have now organized all of that into the, you know, the work that you get into there. What message does it send to the students? I think we're probably sending the wrong message. Whether that's because we're actually sending the wrong message or because we're trying to send one message and it's coming across as a different one. So I think people need to work a little bit harder on ensuring that our the things that we're telling students are actually coming across the way that we're intending. And this comes back as a theme. If we think about the fact that everything we do sends a message to students, what is the main message that students hear from your practice? And is that the message you want to be sending them? Yeah, I don't know. I think I probably need to send more. I would need to send surveys out to really understand what messages are coming across to students, and then try to figure out whether or not that's really what I want to be telling them. What are some challenges you anticipate you will experience in implementing the strategies used in this chapter, and what are some ways to overcome them? Again, trying to organize the classroom is not necessarily something you can do. But as Peter said in the FAQ, you can organize the desks, you can organize the students, and you can organize your behaviors. So having 2 out of the 3 is pretty decent, right? Like put desks all the way around, or no, put chairs all the way around a desk instead of strictly keeping those groups separate from each other. So if we had, for instance, 2 groups of 2, or no, we had 4 groups of 2, whatever. You say like, okay, these 2 people turn around and see those 2 people. And like these 2 people go onto the sides of this group over here. So I don't know. You can come up with any sort of ways to reorganize things and make it work in the way that you want it. All right, we're going to snooze those ads here. Examples of thinking problems that go at the beginning of a lesson. K through 2, jelly beans. You have 16 jelly beans and 4 jars. Place the jelly beans in the jars so that each jar either has 3 or 6 jelly beans. Are there some things that are not possible? Place the jelly beans such that each jar has 1 more than the jar before it. How many different ways can you do this? Place the jelly beans so that each jar has twice as many as the jar before it. Okay, how about 3 times as many? Grades 3 through 8. 4 numbers. Select 4 numbers from 1 through 9 at random. So 4 digits at random. Using these 4 numbers and any operations you like, make the values from 1 to 30. Right? Addition, subtraction, multiplication, division, and any others that you have learned about. So square roots, sure, if you've learned about it. Exponents, whatever else you need, go for it. Grades 9 through 12. Gold chain. You are backpacking through Europe. You have 1 month, 30 days, left until your flight home, but you have run out of money. However, you have a 50-link gold chain that you bought on your travels, and you found a hotel that is willing to accept 1 link per night for payment of room and board. However, the manager wants payment every day, and they're willing to help you by cutting links for you. The problem is that they want 1 gold link in payment for every link that they cut. How many links are you going to have left when you fly home? So every time they cut links, they're also going to take 1 as payment. Okay. So next time, we're going to be talking about, next Monday, how we answer questions in a thinking classroom. So this is Chapter 5. The picture on this one is good because, yes, this happens all the time. Are we right? Is this good? All right. Wednesday, we're going to be back with cracking the GRE math test. Tomorrow, we should be back with 9 souls. So we're going to start our run on 9 souls. And Friday, we should be back with Against the Storm. And then Sunday, we should be back with Satisfactory. So anything other than that, probably Elite Dangerous, but there's a good chance I'm just going to be playing that offline. So I hope you all have a good night. We're going to start a raid over with Dr. Gold. who is doing math tutoring. So if anybody has any particular questions in math or in physics, go ahead and ask Dr. Gold. I hope to see you all tomorrow, and hope you have a good night. My name is Obi-Wan Pez. This is N Simplex Pachinko. Catch you next time.